So on today's video, after the homework resolution, we'll be working with our scripts and giving them an overhaul so we can improve the game. So let's get started. Okay, so let's start with the homework. Let's select our cube and open our player movement. Here we need to check another key. We can copy one. Let's copy this one. Paste it here. The key will be T. And let's delete this inside. Let's create on top here a reference to both cameras. So private game object. Let's say third person camera and top camera. Don't forget to make it serializable so we can actually see them on the inspector. Let's go back to Unity and let's move it here. So our third person camera and the top camera. Let's go again back to the script. So when we press T, we want to toggle between cameras, right? So let's create a function for that. Right, void toggle camera. And here we just say if top camera dot active self, we want to enable the third person camera and disable our top camera. Otherwise, we do the opposite. Here it's false and here true. So if you save that, go back to Unity, make sure that one camera at least is disabled. So we start on the third person. Let's play. If you press T, you can see you change camera. But if you hold it, you get this mess. So let's change the input type. Go back to the script. And instead of get key, you need to get key down. Save it. You try that again. It works fine. And that was all for the homework. So on today's video, we'll do a couple of things to improve our code and our game. Let's start by opening our player movement. And here you want to write times time dot delta time. Every time you move an object on the scene, you should use this, at least for the most of the times. It makes the movement consistent from computer to computer. And let's also clamp our max speed. So let's create another variable here. And by the way, we can make these ones private. So private, and on top you write serializable field. Let's create another one here. Private float max speed. Okay, now let's scroll down to our movement. Where is it? Here. And we won't be using this anymore. Let's comment that or delete it. And let's create two new vectors. A vector 3 force equals transform dot forward times speed. That will be our force that we transfer to the cube. Now other vector, velocity equals rigid body, our current velocity, plus our force. Now we need to clamp this. So rigid body times dot velocity, equals vector 3 dot clamp magnitude. We want to add the velocity and clamp it to max speed. Now if you save it, open Unity, give it a max speed of, I gave it 8, you can choose whatever, like 10. If you now play it, you can see, if I didn't die, wait a second. Okay, you can see that our movement is clamped now. We don't move like crazy anymore. Now let's improve our rain manager. Let's open it. Now let's create a new reference here. Private game object ground. Let's make it serializable. And now on the update function in the start, let's say that ground dot local scale, dot transform dot local scale equals vector 3, copy the span range x, comma 1, comma span range z. Here write new before, like so. You also need to divide them by 10, because the scale of the plane, when the scale is 1, the size is 10, so we need to divide them by 10. And you also need to convert them to float, because currently they are int, as you can see here, and it will mess up with the scale. Like so. Save, go back to Unity. On the rain manager, you can drag the ground, which is a plane. And now let's say the minimum is 10, the max is 44, and max 44. If you now go ahead and press play, you can see that the size of the ground is the same size that the span radius. So let's do that again. You can see each time you play it's different, and the ground is corresponding. Now let's make the ground shrink over time. Let's open the script again. And now on the update, you just need to do ground dot transform dot local scale equals vector 3 dot lerp transform dot local scale 0 dot 1 and the speed times time dot delta time. Let's create the speed variable up here, private float speed, make it serializable. Let's start it by default to 1. Oh, sorry, here needs to be a vector. Just write new vector 3 0.1f 0.1f 0.1f. No, the middle one can stay 1. because you don't want it to change on the y-axis. So it should, yeah, like so. And here it's ground dot transformers local scale. Yeah, right. So if you try that, you can see that the ground shrinks now, but it's way too fast. So let's change the speed to 0.05. You can see that the ground now shrinks, but it's much, much slower. You can play around with the values. Now we need to also shrink the spannable area. So let's go back to the script. And here we just write span range x. Let's make it a float. We should maybe, yeah, let's instead of doing all this, let's just change it up here to float. Like so. Yeah, like that. And here, so span range x equals madef dot lerp span range x to 0.1f at speed times dot delta time. Do the same for the z. Don't forget to change here the to z. And let's try the game now. You can see it shrinks according to our plane. One last thing we need to do is to destroy the balls that fall down, and our player also, if we fall down. So to fix that bug that you just saw, that the player doesn't fall normally, go back and open the player movement script. And here, instead of vector tree 0, you need to write a new vector tree 0, comma, rigid body dot velocity dot y, comma 0. Save that. And if you play the game now, let's fall down. You can see that we can fall down normally now. So let's now destroy everything that falls down. We can do that simply by going here and create an 3D object cube. Let's increase the size to 99. We don't need to increase on the y-axis. 99 is too small, maybe 1000 by 1000. Yeah, that looks better. And we don't need a match render, so deactivate that. And let's add a new script. Let's say destroy out of bounds. Let's open. And here we can delete the start in the update. We don't need to do much. Just write void on collision enter, destroy collision. Collision dot game object. Save that. Go back to Unity. Let's try that again. let's fall. And you can see we destroyed our player. And the spheres, when they fall down, they also get destroyed. Okay, and you are left just with one bug. That's when we die. Our camera also gets destroyed and we have an error. So if you die, there's no camera, so we get this error because our player got destroyed along with the camera. So that will be the homework. Try it and figure a way to fix that bug. It will be harder than the previous homeworks that I gave you, but it's a good way for you to try and fix bugs and learn how to do them. If you have any questions, feel free to leave them down below. If you want to follow this tutorial, feel free to subscribe, and I'll see you on the next video.